Okay, this is David Zierler, Director of the Caltech Heritage Project. It's Friday, October 22nd, 2021. Once again, it's my great pleasure to be with Professor Charles Elachi. As always, Charles, it's great to see you.
Yeah, it's a pleasure to see you too.
Charles, today I'd like to start with a question that doesn't belong anywhere in particular in the chronology, but I only thought to ask it because of the research I was doing yesterday. So I was in the Caltech archives looking at the papers of William Dreyer, and I saw that he had a whole proposal about creating a JPL medical science laboratory, and the prospectus that he wrote was in 1973. Are you aware of this, of any research into medical health issues that JPL was involved in?
No, to be honest, I really don't know that. No, I'm not aware of it. In 1973, yeah, I was at JPL, but I was way down in the bottom of the organization doing my research.
Now, of course,
I'm not aware of that.
To fast forward all the way to 2020, JPL did very important work on ventilators during the COVID crisis.
Yeah, that I'm aware of, because the interesting thing at JPL, we have very imaginative engineers and they love working on challenging problem. And because the COVID was such a major, impact, so some people had some ideas, so they went and very quickly they developed some of these ventilators at much lower cost. And I think they have been used in a number of places.
Was the ventilator project, did it have some orientation in JPL? In other words, is there a part of JPL that does work that's relevant to health sciences?
Well, we have a group at JPL or an activity at JPL to do innovative things. And usually what we do, what part of our philosophy is that if people have interesting ideas, even if they are not 100% aligned with what we are doing, but they are engineering idea or capitalize on the engineering technology we have. So we usually encourage them to go and do that because you can never tell what comes out of these things. Many times new inventions come out from nowhere if you are working in a completely different field and something new, come out. So these, because of the capability of JPL in doing miniaturized things, electronic things. So a number of people, and I know the management at JPL encouraged them to do that because it was a national challenge. So people come up with innovative ideas and we let them go and work on it. And I wouldn't be surprised that something will come out of, that development, which could benefit, some of the work we're doing at JPL for space missions.
Charles, it's a theme we've talked about before, and it's one that you mentioned many times in your public lectures as JPL director, and that is the value of competition. I wonder if you can talk about that within the context of being an immigrant to the United States and recognizing the way that the United States embraces free market capitalism, for which competition is central.
Yeah, no, absolutely. I always say one of the biggest benefit that leads to the leadership, be it economical or scientific, is the fact that there is free competition in a constructive way, on doing that. And I remember at JPL, just before I became director, up to that time, almost all the missions were given to JPL. So if it's a planetary mission, automatically JPL gets it. Then NASA decided in late 1990s that they want to do competition on some of the planetary missions. And there was first reaction, people had a negative reaction. The employees, now we have to compete to get these things. But I came from background, even at JPL, where scientific instruments are always competed. They always were competed for the last 50 years. So it was a natural for me that you have to compete, to get something. So I in a number of meetings with employees, I told them, look, guys, you should look at competition as a positive thing because it creates, innovation, and ideas. And I told them, look, if we don't win the competition, shame on us. If we really think we are the best organization in planetary exploration, we should be able to win the majority of these things. And I always said, look, and then there was a question on should we share all our capability with other people? I mean, what we develop and make it public. And I told them, look, there is no way you can hide things. And if you hide them, it doesn't keep you at the leadership. The best way to stay a leader is to run faster than everybody else. So that's, and I always give an example, like let's compare to the Soviet Union, because I went to Russia as the Soviet Union was opening a little bit. So I was invited to go to their space agency and I visited their labs. And what shocked me is that even that they were very good, but one lab did not know what another lab is doing. Everybody was hiding, their thing. I mean, that was their system. While here, I go and give talks on everything we do everywhere, and people come up with new ideas, and I share my ideas, they share their ideas, and we get better by doing that. So for me, that was a comparison of how openness and competition really allow you to play a leadership role, and really move things much faster than if you have a more autocratic system.
Charles, of course, President Bush, the 43rd president, he made no secret his love of space exploration and his admiration specifically for JPL. What did that mean for you as director to have such a fan of space science in the Oval Office?
Well, sure, it's very exciting, to do that because, you could imagine, he has probably hundreds of things every day that he has to worry about. And taking the time of actually watching, I think it was after the landing.
The Mars landing, yes.
To sit down and watch the landing and watch the helicopter. It was very rewarding, to see that. And the same thing was, every time we had a landing, the president called, the team at JPL. So we had the Bush son, Obama, and now Biden. And in a sense, what almost all of them said is that by watching what you guys are doing, really uplifts the spirit of the country, because it shows that if we put our mind to do something, we can do things which seem impossible. So that was the rewarding part about it. Not only that they acknowledge what we're doing, but the fact that they acknowledge that what we do is uplifting and inspires the young people. I mean, that's a big reward from what we get. And it reminded me of a story that when we landed Curiosity, and I had as guests the head of the French Space Agency and the deputy head of the Russian Space Agency. I invited them to come, and they were in the mission operation room. And after the landing, we went out to the entrance hall, and they came to me and they said, "Congratulations, Charles, only the US can do this." And I felt so proud, hearing that, from the French and from the Russians, that it really reward all of that hard work on doing that.
When you're getting ready to talk to the president, when you're on the call, when Sean O'Keefe is in the room, what are the protocols? What are the things that you have to keep in mind in talking to the president?
Well, they really didn't give us many guidance. So we were sitting around the table, and it was on the speakerphone. And Sean O'Keefe was not with us; he was in Washington. So the key thing we were told is just make sure you listen to him, not to interrupt him. And he was very gracious. I mean, it ended being a conversation, back and forth after he did the congratulations. And then at one moment, I told him, "Well, Mr. President, if you come and visit, we'll let you drive the rover." I'd love to do that, but my Secret Service won't even let me drive my golfing cart. So he was very, very humorous, about it. And then when President Obama called, he was on Air Force One. So that was kind of interesting. It was a different, setting. So in that case, we put him on a speaker, for everybody to hear, the conversation. So everybody was lined up and I was standing with the key members of the team because it was also video kind of thing. And the same thing, it was after the congratulatory note. So it was a conversation going back and forth. And in case of President Obama, he said, wow, I was watching the landing, and you guys, I didn't see any one of you wearing a tie, because he's accustomed, like at the Johnson Space Center, everybody's in white suit
Right,
and
right.
and a tie. In our case, we had our blue shirts,
Yes.
knowing that. So they all had this sense of a humor, a kind of personalized sense of humor.
It was a wonderful transcript to read between you and the president. One very interesting thing you said when you invited him to come out, you invited him to discuss, of all things, string theory. What were you thinking? Why string theory of all things to discuss?
Well, because it's the one which always when we have young people, kids coming, they always ask about string theory. They have no idea what it is. I have no idea what it is. I have no idea to explain it. But it's kind of fascinating. I think people who are outside the scientific field, as well as some people in the scientific field, get fascinated with this exotic thing like string theory, Big Bang, all gravitational waves, things which are kind of very hard. You don't see them in your day-to-day life, and they are very fascinated about these things. So.
A very interesting and funny question. After Deep Impact, whose idea was it to have the band The Comets play at JPL?
Oh, no, it was our public relation guys. And they thought, that would be cool, to do that. And so we invited them, to come. And they were very gracious. They really agreed to come. Now, they were a hell lot older than what we remembered. And they thought it was cool, because we were impacting a comet. And it was a great party. So we had it, in the mall, outside JPL, because we had kind of the tradition that when we have a landing, if things are successful, we have some kind of an event in front of the main building. And usually we have a band at JPL, that a number of people are musicians. So they usually play on that one. But on this one, our public relations say, let's invite the band, the real Comet Band, on doing that. And it was and people were dancing, and it was a great event.
Charles, we talked in great detail during the time when you were selected for JPL, the way that works with Caltech Leadership. In 2006, with the transition from President David Baltimore to JeanLuc, as Vice President of Caltech, as JPL Director, what role does JPL have institutionally, or the Director specifically, in these decisions leading to who will become the president?
That is a very interesting question. Basically, what happened normally, the Board of Trustees form a board committee, but also they have a faculty committee, which basically is mostly faculty, and they do the first, if you want, come up with a list and do the first filtering before we do that. JPL normally is not involved in the president. We have JPL employees involved in the selection of the director or the search committee for the director. But for the president, it's all mostly faculty. But then, the chair of the faculty committee, they did interview me to ask about what are the challenges at Caltech. Do I have any suggestions? So they did engage JPL. But in the case of JeanLuc, it was really interesting because all of that is done in very discreetly. But one day I get a call from Kent Kressa, who was the chairman of the board of Caltech. And he said, Charles, we are at our final candidate. But when we talked with him about being the president, he said, well, I know JPL is a big part of Caltech. I'd like to meet with the JPL director before I make my decision. So Kent Kressa was asked me, will you be willing to take him to JPL for a couple of hours? And we decided to do it on a Saturday because we didn't want to let the cat out of the box. I mean, people seeing somebody walking around. So I went to pick him up from the Huntington Hotel, which is now called the Langham Hotel. And
so now, was it hello or was it bonjour?
Well, he knew that I was educated in France, and I knew from his name as soon as they told me. I never met him before. I mean, I knew about him because he was at Georgia Tech as a provost. So I drive there, and here he come with Dave Stevenson, who was the chairman of the faculty committee. So Dave just came to introduce us. So we talked in French, bonjour and so on, and JeanLuc got in the car, and I told JeanLuc, I heard that your wife is here. Would she like to come? He said, "Oh, will they allow her to go in?" I thought, "JeanLuc, I'm the director. I can take anybody in." So he went running back, brought Carol, with him. So I drove both of them to JPL and we chatted in French. And then I gave him more information about my background, where I went to school and so on. And then we got to JPL and we spent about an hour in my office and I told him about the relationship of JPL with Caltech, the campus, the history, our connection with NASA, what are the challenges that are coming up. Fortunately, everything was going very well. At that time, it was after the landing of Spirit and Opportunity, and we were getting ready for Curiosity. Then I took him to the museum, and then I took him to the high bay where we were doing some assembly, of our spacecraft. And he was delighted. So shortly after that, he accepted the offer of being at Caltech, and we had a great relationship. I mean, I used to meet with him every other week. And one interesting thing I remember, when we were doing the landing on Curiosity, normally the president of Caltech sits in the viewing area with the VIPs, because we got senators and congressmen and so on. JeanLuc, being an engineer, I said, "Charles, is there a way I can be on the floor next to you in the mission operations?" So I told him, "That's not normal, but sure, we can arrange it for you." So he was sitting there, he and I and the administrator of NASA. And him being an engineer, he was really engaged.
Yeah.
He loved, him. He was a civil engineer. And I remember once we landed successfully, he and I hugged each other and did a couple of steps of dance, together. Because, and he told me that after that was probably the highlight of his stay at Caltech. As a matter of fact, in his official picture, of Caltech, which is at the Athenaeum, we have a painting of each and every president. In his painting, he had the little rover, in the painting.
Yeah.
So it was great. And then when he left, he was always very generous with us. I remember he and his wife had a house in New Mexico. And then they sold the house, so they brought all the furniture back here. And my wife and I have a house which is very southwest, and we collect southwest carpets, furniture. So they offered us their furniture, what they had, to put in our guest house. And so I gave him a check for it. He took the check and he tore it out. He said, "No, that's a gift." So my wife and I decided to give him as a gift a model of the rover. So we bought it, and he was ecstatic with it. So, and I remember he had it in his office, when he was in Saudi Arabia, and then in France, he sent me pictures, of it. So we had a great relationship.
As an engineer, was there any particular value in having him as president of Caltech at that point?
Well, I mean, it's, Caltech kind of goes back and forth between engineers and scientists.
Yeah.
So Baltimore was a scientist, JeanLuc was an engineer. Before Baltimore was an engineer, and then after we had Tom Rosenbaum. Both of them, because at JPL were both engineering and science. And almost all the presidents I dealt with were very engaged with different activities at JPL because they are always very broadband. I mean, the presidents at Caltech, they have a very broad perspective. So, there was nothing particular, but he always asked, when we met, always a lot of, when there are issues and challenges, he was curious to know the engineering aspect of it. So, and having that kind of experience, be it a scientist, Nobel laureate, like in the case of David Baltimore or JeanLuc was member of the Academy, Everhart before him, they carry a lot of clout with NASA, because NASA realized, because most of the people at NASA are also engineers or scientists. So they connect, with them versus having somebody purely administrative. So, there is a benefit, to do that. But usually the president at Caltech trusts the director of JPL to work the detail, all the engineering issues at JPL.
Charles, that same year in 2006, you announced new policies on transparency at JPL. And I'm curious to what extent that was in coordination with NASA Administrator Mike Griffin's initiative on transparency, and to what extent that was a homegrown effort at JPL?
Well, at JPL, it was always a homegrown effort. I mean, transparency was a key factor. Matter of fact, usually always when we have new employees hired at JPL, I used to go and meet with them. So usually we used to give them a one-day entrance briefing, if you want. And it used to be on the first Monday of every month. So I used to go for like 15 minutes or half hour and welcome them. And I always used to emphasize that one of the key principles at JPL is openness and transparency. And I used to give them a quote basically saying that, look, don't try to hide things. Don't try to sugarcoat things. Just be completely transparent on things. If you don't know something, say, I don't know it. If something bothers you, say, that bothers me. We have an issue here. Because I told them it's a hell lot better to know about the problem before we launch a spacecraft than after we launch it. Sooner or later, we're going to get that. So we really, so that's one of our core principles is openness and transparency. Now, Michael Griffin, emphasized that at NASA, and we emphasized it also at JPL, but it was something completely normal, for us. And I think part of it comes from Caltech, the campus at the university. I mean, the faculty will not hide anything. They are completely transparent. They say what's on their mind. They don't care who doesn't bother or not bother on doing that. So I think it's that culture of being part of Caltech, which created that kind of environment or atmosphere.
Charles, in thinking about the Dawn mission that looked at protoplanets and dwarf planets, I'm curious if JPL worked with Mike Brown on the so-called Pluto killing mission, demoting Pluto from our 9-planet solar system.
I'm not aware of that, that there was any connection, in there. But, Mike, his office is across the hall from me. So clearly what he did on Pluto, which I think was the right thing, I mean, he was just taking it in a very scientific approach of, we discovered a lot of objects which are even bigger than Pluto way out. So there is no reason why to call Pluto, a planet. It could be a minor planet, but some people were offended that it was called minor planet versus a regular planet. But, the Dawn mission was going to Ceres, and which was pretty big, asteroid. And I think in the early days, a couple of 100 years ago, astronomers thought that Ceres was a planet because at that time they just saw a dot, and then after they found the size of it, so it became a minor planet or a large asteroid. So I didn't think Mike was directly involved in that aspect. I'm sure scientifically he was interested, in it. But what he did on Pluto was a proper thing. Some young kids didn't like it, and some astronomers didn't like. Particularly, there was a mission going to Pluto, so the people on that mission kind of felt left out. They fought it, but the Geophysical Association, which names these things, agreed with Mike about that.
Charles, you've talked many times about the importance of robotics in developing a permanent mission on Mars. Were there any particular advances in robotics happening at JPL or at Caltech that made you particularly optimistic at this time to emphasize the importance of robotics?
Well, robotics, most of our works have been in robotics, particularly on spacecraft. But the key advance happened when we started developing rovers or developed the technological capability to rovers. So we started with Pathfinder in the late 90s, and that became quickly apparent to us that having the ability to move and explore more areas, really makes a big difference. Because, when Viking landed, all what it had is an arm which went about a few feet away. And you could see rocks in the horizon, which seemed to be very interesting, but there was no way you can get to them and analyze them. So after we did the Pathfinder, and then we did Spirit and Opportunity, and then Curiosity, it became clearly apparent that being able to be mobile and be able to go and reach to interesting areas and take your instrument with you and measure those is going to open a whole new horizon. And that's kind of what led also for pushing and for me advocating to do the helicopter, because for me, that was another major jump. I mean, the technology was developed on Earth, to do drones. But then we had to develop the capability which enabled it to fly in a Mars environment, which is very different than Earth environment. The pressure was much lower, the temperature was much colder. So we had to develop the technology for it. And it was very quickly apparent to me that this is going to be the next leap beyond rovers, where you can really send robots all the way to many tens, maybe hundreds, maybe thousands of kilometers, in the future. And Caltech had a role in the sense that there was a lot of research on the robots happening on the campus. There is a whole team which work on both moving robots, walking robots, hopping robots, drones. So there was an interplay, between the campus and JPL on the technology in that area. And that's where I believe that robot will play probably the major role in the long-term exploration, of planets, particularly, in the case of Mars, because humans have a limited capacity, particularly in those harsh environments, how far you can go, because you have to be always suited or inside a capsule. So human would be very limited in, even that they are smarter than the robot, but they are very limited in where they can go. And also there are many risky areas, edge of cliffs, that canyons where the robots can go. And if for some reason they fail, it's not the end of the world. But astronauts will be very, very cautious. So I really believe that the robots, both by themselves as well as an extension of astronauts, are really the way to do exploration, in be it on Mars or places where human cannot go, like Titan, for instance, on doing that.
Now, this question will invariably get to a bit of science fiction because it comes at the intersection of robotics and humans. But does JPL think in the long term, in the way that technology that's not feasible today, but if we want to talk about establishing a human presence outside of our solar system, far-flung concepts like uploading consciousness into a computer or having a robot store human DNA for an embryonic creation at some point in the future. How wacky or far out does JPL get in thinking not just in the next 10 years, but in the next century?
Well, these ideas are wacky, but we love wacky stuff at JPL. Matter of fact, we always think the craziest ideas are more interesting. It is, even if it's only 1 out of 10 will materialize. It's always very, very hard to say, oh, we cannot do this, or that's impossible, particularly when we are talking about a century time scale. Because if we go back a century ago, let's say in the 1900s, who would have thought that at any minute I can walk down, get in a car, get to LAX and fly to Paris, and I'll be there within 10, 12 hours. People would have said that was pretty wacky ideas, at that time. And probably science fiction people were talking about it. So I think these things are possible, as long as they don't break the laws of physics. It gets a little bit marginal when people say, oh, we can go at faster than the speed of light. That I would say that's really wacky. I don't think I'll pay attention. But any of these other ideas, are possible. I still think transporting human consciousness and intelligence is still a far way, kind of way of an idea, because it is amazing what the human brain can do. And even today, when you talk about artificial intelligence and computer learning and so on, I'm always a little bit skeptical about adding the word intelligence, in it, because it's really what it is. And from the beginning, I always thought it's really what the computer is doing is enabling to handle a huge amount of data, in a very rapid way, but that doesn't make it intelligent. It makes it a good processor. And now, in fact, I see a lot of articles where people saying, well, maybe we're exaggerating the statement artificial intelligence, or the emphasis on the intelligence word. Because basically all what the computer can do so far is to execute what we tell it to execute. While as humans, we don't execute what our parents tell us to execute. We have an imagination. We can come up with something brand new based on what we have seen or what we have felt. I mean, you look at 2-3-year-old kids, just by looking around them, they can become very conscientious of the world around them very quickly. Computers are not there yet. So, but who knows, 10, 20, 30, 50 years from now, something new might happen.
Are there groups at JPL that are specifically tasked with those questions way out into the future, or it's whoever wants to go there is welcome to?
Yeah, no, we encourage people to think way out of the box. We had, matter of fact, a group at JPL which was working on the origin of life to figure out how did the first cells happen. Now, offhand, you'd say, well, what does that have to do with what you do at JPL? But it does have to do, because one of the objectives is to send spacecraft to other planets and find out what kind, could they have life, on them. So a key thing is to be able to, ideally, we would like to know all the way, how did life start? What triggered it, to create a cell, and then the cell to create, life, is to see if we can see something similar, be it on Mars or on Titan or in the ocean of Europa. So now we have that philosophy, which is from the campus. Basically, the way we put it on the campus when we are hiring faculty, we say, well, our goal is to hire the smartest people and let them loose, let them go and think, whatever. Now, at JPL, we almost do that because we still have to build spacecraft and launch them and so on. But we do let people say, hey, we hire the best people, and if you have some ideas, we have discretionary money that we will provide them, to go and think about crazy ideas, on doing that.
Charles, I asked you a question about President Bush being a big fan of JPL. Maybe that was an easy question to answer. This might be a little harder, but I think it's very important for the historical record. There were reports during the presidential administration of Bush that he or Vice President Cheney or someone in the administration did not encourage NASA to pursue climate change research. And I looked through the record and I couldn't find any statement from you one way or the other. And I wonder if you were taciturn because that was true, but you were not in a position to complain about it, or if that's not true and you never actually got any of that pushback from the administration.
No, I don't think it's not true. No, I don't recall. I mean, people always ask questions, and that's normal. Every time there is a new administration, which comes in, and it's a new people who are, at the president level, I don't think they get involved in that detail, but there are people under them. And always you have people across the spectrum. Some people who love astrophysics, some people who love planetary, some people who love earth science. And always they ask questions about, are we spending the money the proper way? But I don't recall ever at that time, with any of the administration of being negative about Earth observation. There were people on the Hill which were skeptical. I did encounter, talking with some people on the Hill, that they were skeptical in the sense of saying, why are we spending this money on this thing? Is it because, in a sense, because a lot of scientists were saying this is human impacted. Some companies got threatened a little bit, oil companies, and of course they talk with their congressman. The congressman is not very well informed, so they react the same way, on why are we doing it? But I found almost all the time when I talk with people on the Hill who are skeptical, by showing them scientific data, actual data that we're acquiring with our satellites, many of them kind of start saying, well, maybe it is true. Maybe what you are telling us is true. Because, we do show records from our satellite about the ocean rising, about carbon dioxide increasing in the atmosphere. about the warming of the ocean, because we have records which go over decades, from satellite. Melting of the ice, in Greenland. And I remember one specific congressman, which we became very good friends. His name is John Culbertson from Texas. And he was the chairman of the appropriation committee, which oversees NASA. So he was kind of skeptical a little bit about it, but he loved space. He loved particularly Planetary. So he used to come often to JPL. And I remember from the time I met him, that was like shortly after Spirit and Opportunity, or around that time. So that's 2004. So the time I stepped down from JPL, he really changed from being kind of skeptical to asking a lot of questions to becoming a believer, into that what we're doing is the right thing. So in general, the philosophy I approach with them is not to tell them the sky is falling, because that looks like we are too alarmist. So it was more to say, look, this is a major issue. Yes, there are some people who think it's human-made or not human-made, but that's irrelevant. The environment is warming. It's impacting our lives. We really need to do something about it. And even if the human contribution is 10% or 20% or 30%, we ought to reduce that, because otherwise it's going to make the problem or the situation even worse. So by talking more of a logical way instead of an alarmist, way, I think many people kind of change their mind. But going back to your original question, I don't recall ever being told by the administration, that we shouldn't be doing Earth observation.
Okay, that's a very good point to clarify, because there are some reports that suggest that pressure was coming from the administration.
And you can look at the budget. I mean, the budget of the Earth science, it went up and down a little bit, but it regularly continued to be growing. Now, clearly, at the present time, with the Biden administration, there is a positive, urging, because now people are starting to appreciate that really climate change is a big issue.
Yeah.
And it's really impacting us. And NASA is not going to solve it. What NASA does, it will be able to monitor what the changes are happening. And in the future, monitor any policies that are applied. How is that impacting the environment change? By cutting down carbon dioxide, is the planet kind of stabilizing? So that's where NASA come into the picture.
In 2008, it was an amazing milestone. It was the 50th anniversary of the Explorer 1. I'm curious what that get-together was like and how it was meaningful for you.
Oh, no, we had a great party, to do. We always have an excuse to have a party at JPL. But it was a double thing. One, it was because there were still some employees at JPL who were involved in the Explorer 1, as well as we brought some of the retirees.
Oh, that's great.
When Explorer 1 happened, it was a bunch of 20 years old who were, young people doing that. So there was still a number of employees who were still alive. So we had them come over. We had a great celebration. And for me, it had a personal kind of meaning, because Explorer 1 is reading about Explorer 1 was the first time ever I heard about JPL. I was 11 years old reading in a magazine sent by the American embassy in Beirut. And I read about this America launching Explorer 1 from a place called Jet Propulsion Lab. Had no idea what place it is or where it is. So it had a double meaning, both an institutional meaning, a personal meaning, and also still having people who were participant in Explorer 1 still alive.
Charles, was it also a moment of reflection in the ways that JPL had grown since 1958? In other words, in 1958, jet propulsion probably was a pretty good explanation for what the lab did. 50 years later, it's so much more. I wonder if that was an opportunity to reflect on that.
Oh, sure, absolutely, because it was a different JPL. We had the legacy and the tradition, but it was a very different JPL, because in 1958, we really were a jet propulsion lab. Almost 99% of our work was actually propulsion. And the biggest, reason to do Explorer was to demonstrate the propulsion, that we can put something in orbit. And there were some science aspect. There were some scientists at JPL to make measurement, with a satellite. But really, the major feat was the propulsion. And shortly after, and at that time, NASA did not exist. I mean, JPL existed, but NASA, and we were basically a Caltech lab, basically funded by the Army, because the U.S. Army was the main organization funding propulsion, for strategic missile and so on. So shortly after that, when NASA was formed, they looked around and which laboratories know how to say the word space. JPL was one of them. So NASA took over the facility from Caltech, but Caltech continued to manage JPL. And I'm told that there was a meeting, at NASA headquarters, and they were saying, "Oh, we really need to send spacecraft to the planet. Who would like to do that?" And Bill Pickering was sitting there, and he raised his arm and said, "We would like to do that." And that transformed JPL completely from a jet propulsion place to a planetary, or robotic spacecraft, organization. And now we do very little jet propulsion, if any. We only do some work on electric propulsion or on exoteric kind of propulsion, but the traditional propulsion, we don't do it. But the name JPL stayed because has been known, all over the world. Matter of fact, you reminded me of a little event which happened. I'm trying to remember. I think it was before I became director, so it was in the 1990s, where the government had tradition that when a well-known congressman, retired, they might name a building after that person. And I think suddenly one day we found an announcement that the local congressman, I think his last name was Smith, I never met him, that NASA decided to name JPL the Smith Lab. And everybody was taken, aback. What in the heck where did this come from? So then there was all kinds of dialogue back and forth. No, we don't want that. And then they reversed it. But for a few weeks, we were called the Smith Research Lab. And it's like, the other place, the Kennedy Center and the Johnson Space Center and Glenn Space Center. So no, we insisted that, and I think our congressman at that time, even Smith, I think he kind of said, no, JPL ought to stay called as a jet propulsion lab because historically it's well known that way. So yeah, no, we like the jet propulsion lab.
That's right. Charles, a broad thematic question that unites so many of the JPL missions in our solar system, and that is the search for water and the resulting excitements because it possibly tells us that where there's water, there's life. So let me frame the question in a way that might be a bit disturbing in light of the fact that through all of this discovery, all of this water that we're aware of, the life, it's still an open question if it's there. So maybe water tells us nothing about life. Has JPL grappled with that difficult question in a systematic way?
Well, it's interesting. I know for sure my wife grappled with it. My wife is an artist, or I used to be a movie producer of animation movies. And always when I was telling her we were searching for water to look for life, she said, "Why water?" And I used to say, "Well, because that's what we are accustomed to here. Life on Earth evolved." And she said, you ought to be thinking out of the box. Maybe life on other planets is very different. Maybe it's not based on water. Maybe it's based on something else. So keep an open mind. So usually, we do keep an open mind. I mean, I have to listen to my wife, and I always listen to her. And at JPL, many people do think a little bit. And that's why I would think there was somebody, a researcher at JPL, working on the origin of life, because by understanding the origin of life, that the way we know it, it might shed light on how is it different life could happen, on doing that. So yeah, people think about that, but as of now, the only life we know about, or we have experience with, is the life which have evolved through water, organic material, and energy, which is the life here on our planet. So we tend to look at something similar. So in matter of fact, in 2000, The Mars program was called Follow the Water, and that's why we're searching for water. And now we are saying the program is search for habitability. That means look at the organic material or environment which could be habitable, but they are still based on our understanding of what life is, based on carbon. So we look for carbon, organic, molecules, and we look for water, and we look for source of energy. But your point is legitimate. I mean, life could be very different. I mean, there is no reason why it should be identical to the life here. And so it become a philosophical issue. What is consciousness? What is life? How does it evolve? And so, yeah, who knows? It might be very different.
In all of JPL's discovery, all of the data, all of the image, all of the analysis, is there a moment that sticks out in your memory when JPL got tantalizingly the closest to thinking that maybe they discovered life on one of the planets or satellites?
Well, I think probably the exciting part was when Curiosity found molecules which are carbon-based. That means it was a chain of molecules. They were very short because that was kind of what we were looking. Are there any chains of carbon molecules? And it did find, short carbon molecules. So that kind of became exciting, and tantalizing. Is this the beginning of building longer chains, which could become, the kind of life that the other tantalizing time was when the discovery of phosphine in the atmosphere of Venus. But then it became apparent that it was very, very weak signal. We are not really sure, another tantalizing time, again, was the detection of methane on Mars. First, it was detected from the ground, but also it was very weak. And then when we landed on some of the landers, we did detect a very, very faint signal of methane, which was variable, because also people believe that maybe it's generated by some organic chemical activity. So yeah, there were some tantalizing times, but it still fell short of really strong proof that will allow us to say, yeah, we know life exists. So we are still at the stage where we can say, yeah, there are a number of places which are potentially habitable, but we don't have the absolute proof that actually life exists on them or existed in the past.
Because, of course, it's impossible to prove a negative, JPL has not proved that life doesn't exist in the solar system. Where is there opportunity to go back and look closer in those areas where there is the most excitement?
Well, clearly Mars is one of them. And I think when we bring samples back to Earth, that's going to go a long way on us really understanding the composition of those samples and about the organic material in them or the environment in them. But also the possibility of life on the oceans of Europa below the ice. Again, there it's also very logical. If you have liquid water, that means you have the right temperature. We see organic material both in the on the surface and on the plume of Enceladus. So both Europa and Enceladus, we believe that there are oceans below the surface which are liquid, and they are made of H2O and they have organic material. So it has all the ingredients to cook life, if you want, or generate. So these are the ones which are getting a lot of focus, and possibly Titan. And on Titan, there it's kind of the reverse. We have a lot of organic material based on carbon. The whole planet or the surface of the planet is made of organic material, but it's so cold that the water is all frozen. But there could be life in a frozen environment. So here we have a number of tantalizing satellites and planets which have all the ingredients of what led to life on Earth. The question is, did evolution kick off and lead to life on those planets? And I think those would be answered, I would say, within the next decade to 2 decades. I think we'll have proof, one way or the other, from those areas.
Charles, a fun question. Whose idea was it to beam the Beatles across the universe in February 2008?
Well, I don't recall whose idea it was, but I thought it was a cool idea.
Yeah.
That it was really a cool. No, I think we have a number of people at JPL who are very much into music and so on. So, in the case of Spirit and Opportunity, somebody on the operation team, because in the case of those missions, we had every day to kind of send command to tell them what to do the following day. So we used to have the rovers sleep during the Mars night, sleep meaning not operate. And then in the morning on the Mars time, we used to wake them up. So somebody came with the idea, oh, why don't we send a piece of music to them to wake them up on music in the morning? So every day we were sending, music, the different kind of music. And the people had fun about choosing different kind of music. And then in 2008, somebody came with the idea of sending the Beatles, or Beatles music, across the universe. And, these things, both they were fun, it kind of humanized the whole process, but also the media loves it.
Sure.
And young people loves it, so it kind of brings space down to earth in a sense and give a personal connection. And it makes scientists more viewed as normal people. Because I remember, we had a band at JPL, and we have a choir, and the choir was invited once to one of the events in Pasadena at the Arboretum where they used to have concert. So they brought the the JPL choir, and I was sitting at the table, and there were a bunch of other tables. And I remember after the JPL choir sang, one guy said, "Wow, I didn't realize that engineers can think." So it kind of came to me. I heard them at the table next to me. So I told them, oh yeah, no, we are human like you are. So it kind of humanized when people see that, instead of the ideas that we sit in a lab with white coats and we are nerds and so on, when we do things like this, people say, yeah, these people are like normal people.
I wonder technically if you could explain, how does one go about beaming a song across the universe?
Oh, we just transmit it on our, because we send signals, like radio signal, like the way you receive the songs, on your radio. So that's exactly the communication that we send to our spacecraft. It's the same concept. So we actually record it and code it and send it from the Deep Space Network, the antenna we have around the world. So if somebody living on another planet, the nearest star to us, which is 5 light years away, so when we send that in 2008, by 2013, that signal would have reached, a neighboring planet. So if there are advanced humans on those, they would have received the music of the Beatles.
Was there hope, or is there hope that in sending out these signals that they'll be received and that we can get confirmation of receipt?
Yeah, that's possible. That's perfectly possible because, radio signals propagate across the universe. So if there are other planets where there are civilization with advanced technology, that means that they can detect this kind of signal because they would be very, very weak and they have to be evolved at least to the same technological level as we are, here to be able to receive radio signals. So that means having radio receivers. Yeah, it's perfectly possible, to other, and that's one of the techniques that people are using to look if there are life on other planets, is by looking at radio signal coming from other stars, using big antennas. And matter of fact, now that we have a number of observatories, both on the ground and in space, which will tell us which stars actually have planets similar to Earth. The radio telescope are going to zoom in on those planets or those locations and see if we receive any signal from them. Now, the likelihood is not very, very high, but it's not zero either, because not only you need life to have evolved on those planets, but you need life to have evolved technologically advanced enough that they have developed radio transmitter. We have to remember, we only developed them 100 years ago or 120 years ago, here through our whole lifetime, of life on our planet. It's only very recently that we evolved to the technological stage to send signals. So yeah, if there are other planets where there is human or life which have evolved to our stage of technology, they might be transmitting signals, or we might be able to receive their TV programs.
Is JPL involved on an institutional level with organizations like SETI that are dedicated to this research?
Well, yes, we work both scientifically. We have scientists to work with them. We have engineers. It's not a major effort at JPL, that we are involved in, but we do support, them. Sometimes people have used our deep space antennas, except our antennas are very busy communicating with spacecraft, but because they are very big and very sensitive. So yeah, we do exchange information about technology, but that's not a major focus, at JPL.
Charles, when President Obama came in, along the same lines of what I was asking you about President Bush and climate change, where the media might tend to overplay these distinctions, President Obama cast himself as a very pro-science president, and of course I think he very much was. In light of that, did that change anything for you and JPL when he came into the White House?
Well, it always helps when you have an administration which is scientifically, inclined or supportive, of science across the board. I mean, it does impact NASA, in a certain way. And yes, when the Obama administration came in, they put more emphasis on the robotic because it's driven by scientific objective versus the human program. Again, it didn't cancel the human program, but it's an emphasis of where you put the emphasis. Because in general, NASA budget is kind of stable. It grows by inflation. But then within that budget, you have pieces which are for science, pieces for technology, pieces for human. So depending on what is the philosophy of the administration, you have a change in emphasis, a little bit of emphasis. Not dramatic. It's not suddenly we got flood of money, but it was more sympathetic, with requests, for doing robotic missions. So yeah, it does happen. And then when the Trump administration, there was more emphasis back on human. Now with the Biden administration, Biden administration, there is again more emphasis on planetary and Earth science. So that's common, but in general, it's not a drastic, change of emphasis.
Were you able to develop a relationship with science advisor John Holdren at all?
Yes, we did develop that. Matter of fact, he came to the landing of Curiosity, and he was a keynote speaker after the landing, and he was very gracious and very articulate, in emphasizing the amazing things that American technology can achieve and the advances that it can achieve. So I remember after the landing, he was in the mission operation room in the viewing area. So after the landing, he came down and congratulated all the team. And then when we had the press conference in Von Karman, which is a major auditorium with the media, so I introduced him. So he gave the first talk, and then Charlie Bolden gave a second talk. And I gave the next talk, congratulating the team and saying how exciting, it is. So, he got pretty engaged during that, particularly during that landing. And it's the same, like I mentioned earlier, the emphasis is not only on the advance itself, but on how much inspirational it is and how much it illustrates that leadership in science and technology enable our country to do great things. Not only in space, but also economically, or medically, or whatever the technology can be applied to. So that's what I kept emphasizing to people on there. It's not only because of space. I mean, space is one element, but it advances our whole capability and create an environment of innovation in the country. That if we are develop these things, it creates a spirit of innovation. Like what I call their mighty things. It created across the board, be it in music, in art, in all kinds of economic factor. And space is a good way of doing it because it's highly visible. I mean, people see events in space that we develop much more than, well, a new chip was developed. Now, the new chip might have more impact on our life, like what Carver Mead did. But when you land on Mars, everybody is paying attention to it versus, oh, a new chip was developed. So it's really the high visibility of space which lead to that inspiration.
Charles, and what was, I'm sure, one of your most difficult moments in your tenure as director of JPL, tell me about the station fire in the summer of 2009.
Oh, wow. Yeah, that was really a scary situation because that fire just started kind of a few miles behind JPL, but it came all the way literally to our fence. At JPL, we have antennas on the hill, and I was in my office. I mean, we closed the lab for a couple of reasons. One, because of the fire risk, but also because of the smoke and the risk for the employees. So we shut down the lab for a couple of days, but we were very concerned, about it. But fortunately, the fire department, there is a fire station there is one at JPL, for local, impact, as well as a city fire station next to us. So they were great. I mean, they all went up to the top of the hill, with all their trucks, to protect that. And then they called in a number of airplanes, to come in and drop, fire retardant, in our area. So yeah, I remember being in my office, watching the airplane coming and dumping, all of that. So yeah, it was scary, and we have pictures, of it. And matter of fact, I'm trying to remember. I think because every year, for the holidays, we have a card that we send from the director office to all the employees and all the friends of JPL. I think for that year, we had a picture of the fire saying we survived, we survived the fire.
Given the sensitivity of JPL instruments, with all of the heat and the smoke, was anything damaged in the fire?
No, there was nothing. That was also a big concern. We made sure, because I think I don't remember which spacecraft we were assembling, and we were concerned that despite all the filtering that we do in our chamber, that could create some damage. So we did do extra precaution, covered the spacecraft, but there was no real damage because of it.
I wonder, given all of the work that JPL does in climate change, if this hit a little too close to home in that regard.
Yeah, no, it did come kind of close to home, and I mean, we didn't need that to convince us, but this did come, close to home on doing that, and also the other aspect of it also, which was kind of interesting, is we deployed a number of our instruments, not only for that one, but for other fires also, using infrared instrument to help the firefighters, because with the smoke, it was very hard for the planes to see, where the fire is active. So by using infrared instruments that we developed at JPL, and now they are becoming common, actually they were able to see through the clouds, through the smoke, actually where the fire was active and be able to home in on where to do their drop the retardants.
Charles, I know you love talking to children about space. That's very important for you. And of course, many times, I know from experience, I'm a father, when children talk about space, they express a sense of wonderment for which clergymen and philosophers have as much authority in some degree as space scientists. So when asking those existential questions about who created the universe, or does the universe have an end, or what does it all mean, as an educator, as somebody who wants to teach children, what do you see as your role in terms of what science can answer and what it cannot answer?
Well, I think particularly with the children, it's all of us, when we were kids, we were always very curious. We're always exploring, trying different things. And somehow as we get older, maybe because of the experience of life, most of us tend to become more conservative. So we lose a little bit that curiosity, which is essential, particularly for scientists and researchers. Curiosity is absolutely at the heart of what we do. So that's why I always find it fascinating about talking with children, see the excitement in their eyes. And they always ask amazing question. I mean, usually at JPL, we always bring students from high school, from middle school, even from elementary school to tour JPL. Every year we have like 20,000 children who come and visit JPL with their teachers. I mean, we organize it. And every once in a while, I used to go and join them, for the fun of it. And always they had this question, like what you said, how did life start? What was before the Big Bang? How did the Big Bang happen? What's string theory? I mean, things which and one of the most interesting one, I remember, it was a daughter of a friend of ours. I was giving them a tour. She was like maybe 9, 10 years old. And she asked a question that I never thought of. She said, oh, we have the planet named after the god, Venus, Jupiter. Why Earth is called Earth? And to be honest with you, I never thought about that question. So I thought, I really don't know. So I went and Googled it. And it turned out it's related to some German name, which means dirt. So I learned from them something that it never crossed my mind to think about it, So always children make you not only wonder, but sometimes they bring things that you don't think about.
Why having a child be involved in a naming contest for a major JPL mission?
Oh, I thought that was great because this was started to engage high schools, and middle schools. So someone at JPL, again, I don't remember who. I mean, usually people come to me with these ideas. Wow, this is cool. Let's go and do it. It's like, sending the music of the Beatles or bringing the Comet Band to JPL. So that's what I love about JPL. We have a lot of imaginative people who are always thinking. So that started, and again, in our public relations, said, because that's where we have our education office, that would be a great way of engaging, schools and children in naming that. And so we started the concept. It started with Spirit and Opportunity, where that was, I think, the first time that was done by NASA and by JPL, where we engaged schools to name, and not only to suggest names, but also the student had to write an essay, a one-page essay about why they would suggest that naming. And I remember in the case of Spirit and Opportunity, that was the winning name. It was a middle school girl who was born in Russia and was adopted by American parents. And in her essay, she said, that's what the United States represent for me, spirit and opportunity. And that was, it was very touching. And that's probably why she won, the competition to do that. And as a reward for it, she came to JPL. We gave her a tour. We had her scribble her name on the rover. So her name is on Mars. And then we took her to the launch. And then it became a tradition after that. So the same thing we did on later mission. NASA is doing it more commonly now. And the same thing happened with, that we had people, we started by when people visit JPL to watch, let's say when we were assembling a rover or a spacecraft, have them sign their name. And then somebody came with the idea, gee, why don't we scan all these pages, put it on a chip and put it on the spacecraft which is flying? So people can say, well, we have our name on Mars. And that's how we started. Now it's becoming very common. A lot of people put logos or names, on spacecraft, with certain protocol. So it's always these ideas come from innovative, people, and it's a way of engaging the public. I'm a member of a club in San Francisco, and one time we invited a number of those members of the club in when we were doing Spirit and Opportunity, and I had them sign their name and put it on the chip on this. Even now, 16 years later, when I see those people that say, wow, I tell everybody, even now, that I have my name on Mars. And these people are not scientists. They are completely, they are investors. So these things have impact, on the public.
Charles, can you talk about JPL's role within the larger international collaboration to monitor potential asteroid impact threats to planet Earth?
Yeah, no, that is now JPL is in almost every program we have or every mission we have international collaboration, on this thing for the simple reason that, there are smart people all across the globe. The more eyes that are watching for asteroids, the more likelihood that you'll be able to do the survey, and the more telescope. The European have major telescopes, particularly in the southern hemisphere in Chile, in addition to the telescopes we have in the U.S. And JPL has, and there is a center, by the way, which is called, I don't remember the exact name, but something like Asteroid Survey Center, where anybody who detects asteroid contact that center so they can distribute it to other places, so they can watch those asteroids. And at JPL, we have a center, a group of people which do the navigation or do the tracking. So if they get information about the track of an asteroid, they can project in the future using traditional celestial mechanics for the next 50 years or 100 years, where would that asteroid be? And is there likelihood for it to impact Earth, or how close it will come to Earth? So that's a team at JPL. So we are very engaged with the international community, and they do that very quickly, because it could be a telescope in Chile which detect an asteroid, and they want to have that center at JPL project where it will be a couple of weeks later. So a telescope, let's say in Hawaii, can look at it, and track it. And that's distributed now easily, on the internet. So it's done very, very quickly. We are very involved in the whole international program about surveying asteroids, tracking them, and particularly projecting, in the future. And now JPL is putting together a mission which will actually, because one of the challenges about asteroid is you can detect them at night. So during the day, it's much harder to detect them. Or if they are coming from the sun side, they are very hard to detect early enough. So we are working on a mission which will be launched, I think, a couple of years from now with University of Arizona or Arizona State University, to put a spacecraft, in deep space, which will enable it then to detect asteroid and survey asteroid coming from any direction. So that will add to our basically network in addition to the ground telescope. And the hope is that we'll be able over the next decade to basically know about 99.9% of the asteroids that are around, particularly the ones which are come close, to Earth in the future, and projecting over many years. Because if we know that, and if we detect them early enough, then it's much easier to deflect them. So if we know an asteroid is heading toward Earth potentially 5 years from now, or in it's very easy to deflect by a little bit and avoid it hitting Earth. If we don't see it until 2 days before it hit Earth, it's a lot harder. Then we duck down and pray.
It gives a whole new meaning to the idea early detection saves lives.
That's right. Absolutely.
So, Charles, heaven forbid, if there was an asteroid that, threatened Earth, threatened civilization, what role would JPL play specifically in deflecting it or even blowing it up?
Now, clearly we will play a major role for a couple of reasons. We don't have a program today to do that, but we are doing activity and research to really understand how do you deflect an asteroid. Example, deep impact. So we demonstrated the technology that yes, if we detect an asteroid early enough, we can send a spacecraft and be able to impact it and deflect it. So in a sense, we have developed the technology and the capability, to do that. So yes, if we detect asteroid which could be of risk to Earth, I think JPL would be playing a major role. Overall, NASA and the government would be playing a role, but JPL would be playing a major role, both in navigating spacecraft toward an asteroid, impacting them, or the technology to impact them. Now, I could imagine the Air Force will play also a major role if the decision is to blow up an asteroid, which I'm not sure it's the best, solution, because if you break it in pieces, they still might come and hit Earth. There might be some pieces which are big enough. So I think people are thinking about, depending on the size of the asteroid and the time it's detected, how early it is detected, there are a number of techniques which can be deployed. And NASA has a program, related to the whole activity of both detecting asteroid, but also how do you avoid them hitting the Earth?
Because
in fact, the mission, which will be launched, I think next year, jointly with the European, which will also to go and have a spacecraft rendezvous with an asteroid and another one impacting it, to refine our technology of how much it gets deflected.
Because you love movies so much, I'm curious if you saw the Bruce Willis movie Armageddon, where they were oil drillers.
Oh,
Is that pure Hollywood? Is that a feasible solution? Can you land on an asteroid and drill into it?
well, yes, you can land on an asteroid and you can drill, into it. Now, I mean, all of these dramatized things, to make them a really attractive movie. But no, what happened in that movie is very logical, very reasonable, doing it. Yeah, you can land, in fact, landing on an asteroid is a hell lot easier than landing on Mars. Because in effect, because the asteroids have very little gravity, because they are not very big, really, when you say landing, you're really rendezvousing it. You come very gently close to them and you touch them and you land it, on them. Now, for people, to be walking around and so on, it is a challenge because you have almost no gravity. So you really are almost like huge hopping. Every time you kick yourself a little bit, you go hundreds of meters, away. So there are a little bit of science, a little bit of exaggeration there of being able to walk on them. But that technology is perfectly feasible.
Charles, as prelude to questions about the Kepler exoplanet mission, and in light of the fact that exoplanet research is so incredibly exciting right now, how far back in your tenure, either as director or just working at JPL, were exoplanets something that, first of all, we knew about, and second of all, we had instrumentation where we could do legitimate research on them?
Yeah. No, I was very heavily involved in that because I remember in late 80s, Lou Allen was the director at JPL, and I was the division manager of the science division. And one of our scientists, was an astronomer, comes to my office one day, and he said, "Look what I've seen." He had a picture taken with a telescope of Beta Pictoris, which is a fairly close star. And it showed what looked like a haze around it, like rings around it. And he said, God, that star might have rings. And if it has rings, it might have planets around it. So I remember going to the director at, Lou Allen at that time and showed them that picture. And I thought, maybe we need to start thinking about some program about exoplanets, what we need to do. So, of course, we sent that picture to NASA headquarters. The head of science at NASA, his name was Wes Huntress at that time. He was a scientist who used to be at JPL, in the same division that I was in. He said, Charles, why don't you chair a group to look at techniques to detect planets? So I actually formed a group with another colleague by the name of Chaz Beischman, and we invited a bunch of astronomers to come and spend a couple of days of brainstorming. Some astronomers turned us down. They said, "Oh, that's too esoteric. We don't think, that's worth our time." Some astronomers actually came. So we had a 3-day meeting on campus, matter of fact. And we generated a report talking about the different techniques which could be used and they ranged from looking at the motion of a star, which became that's how the first planet was detected from the ground, but also to look at techniques from space. Also, there was a technique about being able to look at the brightness of the star, and when a planet moves in front of it, it blocks part of that star. So by looking at the intensity of the star, which is what led to Kepler, another technique was to use interferometers, which will allow basically to block the light from the star itself so we can see the planet. and technique, which is a coronagraph, which does the same thing as a thermometer, but a different techniques. So we actually wrote that report, and at the beginning, it was not, people took it as another report, but very quickly after that, as more and more stars were being detected from the ground, then that report became more serious, and then people started to propose, missions, for doing detection of stars. And Kepler was the first NASA mission, to fly in space. And that idea was from a gentleman or a scientist at the Ames Research Center. So he was a key advocate for it. And that technique was pushing the limit of sensitivity of detection. Because when a planet comes in front of a star, it dims its brightness by like fraction of a part per million, right? So you need to have very sensitive detectors, and you need an array of detectors so you can look at many stars at the same time. And that was about the time when the CCD arrays were becoming more capable, building very large arrays. So it was a combination of an idea, which that scientist was advocating, and the technology. So they submitted it at the Ames. We worked a little bit with them, but Ames submitted the idea to NASA, and it was selected. But then NASA said, Ames Research Center doesn't have a lot of experience in building, instrument and spacecraft. Maybe we should look at a center which have an experience to build that mission. So they asked both JPL and Goddard to submit proposals to NASA about how we would approach building it. And to make a long story short, NASA ended selecting JPL, but the principal investigator continued to be the person, from Ames Research Center. And that's how Kepler, came about. And then out of that mission, we found that literally thousands and thousands of stars actually have planets. And that mission looked at a very small part of the sky using that technique. And as a result of that, then there was a number of missions after which were proposed, which had broader coverage, and the technology had evolved by that time. So we had more sensitive detectors. So now there is a mission from Goddard, there is a mission from JPL, and there is a mission from Europe. So this is becoming now a common technique. But if you go back to when we wrote that report, which was in the early 90s, it was a very esoteric. We knew it's feasible, but the technology was kind of not ready yet, to do that. And NASA invested a lot of money in developing the technologies, both for the coronagraph as well as for the, for the interferometers, as well as for the arrays of sensitivity. And now, both on the Jim Webb, there will be some capability of a coronagraph to look at planets. There is a mission called the Roman mission, ROMAN, named after a person who used to be at NASA a long time ago. And that mission has a full-up coronagraph being built at JPL to actually look specifically at planets by blocking the light from a star and looking at, at possibly the light from a planet. And in the latest decadal survey, which is happening as we speak, they haven't yet made it public. One of the mission which is proposed, we don't know, is also by JPL, is called HEBEX, which is a mission which is even a bigger telescope, which will use a coronagraph to actually dedicate it to look for planets, kind of Earth-sized planets to Uranus-sized planets. So that whole field, I think I would trace it back, both to credit goes to the scientists at JPL, which did Beta Pictoris, but also to the scientists in Switzerland who won a Nobel Prize, who were the first people who actually detected, a planet around a star.
You talked about the earliest proposals in the 1990s. So fast forwarding to 2009, what were some of the key technological developments that made Kepler possible after these 20 years?
It was clearly the focal plane, the detector. So that, the telescope was fairly straightforward. There was no challenge, and the spacecraft was straightforward. but it's having a very large focal plane of CCDs like your camera, but much, much larger and very, very sensitive. That means we can detect a very small, reduction in the bright star. And that technology was heavily based on Defense Department technology, because the Defense Department is interested in doing these things so they can monitor, like when launches are happening, see the plumes of launches from space. So clearly a lot of the technology that was developed by industry for the Defense Department, we actually used for our purpose. JPL technological capability was calibrating, those detectors. So we have a lab at JPL, which is called the Micro Devices Lab, which is basically capitalized on technology developed in industry, but we calibrate because for industry, calibration is not critical. If you are looking for a plume of a rocket, all what you want to do is detect the plume. You don't care if it's accurate to 1 part per billion. How bright is that plume? But for our purpose, it is critical to look at the changes which are happening to part per billion, and we want to make sure it's not noise, that it's actually a planet which is blocking the light of a star. So that calibration was happening at JPL. So that was a JPL contribution other than building the instrument and the spacecraft. And the DoD technology, which was in industry, which enabled those kind of detectors to be available.
And is this advance with the detectors, is the thing that's most important is with exoplanets being so far away, how do you even see them? How are they not blinded by whatever star they're orbiting?
Well, because as it orbits a star, so when the planet is in front of the star, it blocks the light of the star. So we are actually measuring the light from the star, and we see, is there a dip in that light? And will the dip repeat itself? So if you see a dip and then you never see it again, then it's most likely noise or something else. But if the planet is in orbit around the star, so let's say it's in orbit of 2 days around the star. So then you look at the signal, and if you see a dip every 2 days and it keeps repeating, then it's most likely something which is orbiting that planet. And then by looking of how deep that dip is, that will tell you how big the planet is. Because if the planet is bigger, it will block more of the light of the star. So that's how we determine both the presence of a planet, the size of the planet, and then the orbit repetition, or if you want, the period around the stars by doing that. So it has to repeat multiple times before we can say, yeah, that's a proven planet.
Charles, it's as much a philosophical question as anything else, but best case scenario with exoplanet research, we detect a biosignature. We detect a technosignature. What then?
Well, it depends what you get on the biosignatures, because now, what's the focus that people are doing? And we started doing it with some of our infrared telescope, like the Spitzer telescope, is when you look at the spectrum coming from a star. If you have a planet which comes in front of it, you add to the spectrum of the star the spectrum of the planet, the light coming from the planet. And then when the planet goes behind the star, you only see the star spectrum. So by taking the difference, you can extract the weak signal of what's coming from the planet itself. So when it's in front, you have the sun. When it's in the back, you have only the star. So by taking the difference, then you can extract the light from. And we do see some information about the chemistry in the atmosphere of the planet. But as we get more sensitive, then we can get more information about the composition of the atmosphere. Does it change? That means that there is clouds. And particularly one would be able to use a coronagraph to block the light from the star and get the light from the planet by itself, clearly without doing the differences and so on. So then for sure it's all coming from the planet. So by looking at both the time change and the composition, you can learn a lot. Then the next step, if you see, let me take it, methane, for instance, then methane tend to be most likely from organic or volcanic. activity. So there is an organic possibility. It might be coming from cows, which are, on those planets, because that's how we get a lot of the methane here. Or if you detect CFCs, which is what we use as coolant in our refrigerator. CFCs does not exist in nature. It's the molecule which was invented by our industrial age. So that will say, maybe there is industrial activity going on. So you can logically start progressing toward potential industry or life on it. Then the next best step would be to have this radio telescope we talked about earlier, focusing on that star or that planet and see, do we detect any radio signals? Human-made or not natural radio signal, like a radio signal which has a code in it or repeats, or it had certain sequences in it which are not generated, by a natural, kind of phenomena. So there is a stepwise process which could take us closer and closer on potentially could these planets be inhabited.
In what way, Charles, either with Kepler or with subsequent projects, does this also possibly yield insight on turning the camera back at us? In other words, in looking at these exoplanets, are we also looking for evidence that we're not just the ones watching others, that others might be watching us?
Yeah, no question. If we detect signals from them, radio signals, that means they are evolved enough that they can detect our signals. Then there is no question, that they have the technology and the capability to detect any signal coming from Earth. So as of now, that's the best way. Short of UFOs, which I still don't think they have happened. But yeah, if we detect radio signals from other planets or laser signals, that's the same thing as radio, except at higher frequencies. Then most likely that planet or that part of the solar system is evolved enough that they can detect what we are doing, even if we are not transmitting toward them, because if they are capable enough, they can detect just regular TV transmission or regular radio transmission. I don't know if you want them to watch our TV programs, but yeah, they would be evolved enough to be able to detect our signals.
Charles, I'll go there because you already laid your cards on the table that you don't think UFOs have come here. It's a joke question, but I can't help but ask. So as JPL director, they never took you down to Area 51 and showed you all the good stuff?
Yeah, no, and I did. When I was JPL director, I got many emails or inquiries of people saying, we saw these things. What do you think about it? Do you think that? No, and I say, look, it's not that UFOs are impossible. But we really don't have any. You can explain a lot of them by natural phenomena, doing that. Like I was just reading in the news today that some people in the Midwest, they saw flashes of light, in our atmosphere, and it turned out that it was a Russian satellite which was decaying and actually entered our atmosphere. So I think the likelihood of other UFOs coming here is remote. Because the nearest star to us is light years away. So the UFOs need to have traveled literally many tens of thousands of years before they get here. Now, having said that, it's possible that other civilizations develop capability to move at almost the speed of light. And they can get here in 5, 10, 20 years. But that's remote at this stage. And then my next question is, why don't we see them? Why didn't they land and interact with us? If they took all that effort to come to here, then they must want to interact with us, and we haven't seen that. So I'm skeptical, even that I'm a kind of out of the box thinker. There is a limit of how much far out of the box. I enjoy those things, and I enjoy the science fiction, and I enjoy the email I used to get, and I used to respond to all of them on doing that. But I don't think we have gotten UFOs here yet.
And just for a sense of scale, when Kepler or subsequent missions are looking at exoplanets, how far away are they? Are we talking about the Milky Way, Andromeda, beyond? Where are these exoplanets?
No, they are mostly in the Milky Way, and even in the near part of the Milky Way, because again, I mean, most of the observation now, particularly the technique of using a coronagraph to be able to see the planet, because the farther the star is, the harder it is to separate that planet from it. Now, the measurement where we look at the wobbling of the star, that we can look even if we have very far away. But the focus at this stage is in our Milky Way. But also remember, if we detect something in the Milky Way, they could be as far away as hundreds of thousands of light years. So we are talking, I mean, just in our Milky Way, we are talking of huge distances. And there are literally billions of stars. So if we find planets similar to our planet in our galaxy, then most likely they are common in other galaxies also.
What do we know so far about Earth being a common type of planet, a Goldilocks planet? Do we know already from exoplanet research that there are Earth-like planets out there?
Well, I'll be careful being a scientist a little bit on doing that. We know that there are planets which are in the Goldilocks environment, that they are not too close to their star to be too hot or too far away, to be too cold. We know there are planets roughly the size of Earth. We know there are planets which have solid surfaces like the Earth is. Matter of fact, on around one star, I don't recall the name now, where we see like 6 or 7 planets around it, 3 or 4 of them are in the Goldilocks region, on doing that. So I could say that we know now that literally there are hundreds which have been detected, if not thousands, of planets which are very similar, which are in an environment similar to Earth. Now, are they exactly like Earth? Do they have oceans like we have here? How much ocean? That's still TBD, to be determined. But I think with the James Webb Telescope and the Roman Telescope coronagraph, again, which we will be getting data over the next decade, and with larger ground telescope, which will have coronagraph on them, within the next decade, we will be able to take images of planets which are about the size of Earth, roughly speaking. And if they are in the Goldilocks region, we'll be able to determine if they have clouds, if there are changes which are happening in their atmosphere. So we can answer much more precisely that, we have planets which are similar to Earth. Now, does that mean there is life on them? That's the next leap that we have to take.
That gets to the water question from earlier.
That's right.
Were people talking in the early 1990s both about biosignatures and technosignatures?
I think that the idea of detection, or let me call it technosignature, of detection of signal, goes back a long time. Many decades, where astronomers, or radio astronomers actually did do calculations on what's the likelihood that life existed. And they did the calculation by taking, how many stars, what's the likelihood of planet around stars. Then from that, what's the likelihood of looking at evolution on our planet? Over 2 billion years, we have developed technology in the last 150 years to communicate. So you can take that ratio and you can multiply all of these, and they came up with positive numbers that, there is likelihood that some planets exist around some stars which are at the same level of technological evolution. Therefore, there is likelihood of techno-signatures. The question is how far those planets are and when will that signal reach us? If a planet is 60,000 light years away, it will take 60,000 years for the signal to get here. So, the techno-signatures, people, I would say many decades ago, people thought of that. And the biosignature, people like Carl Sagan conducted experiments, on how could life have started, by kind of zapping mixture of organic material and be able to generate organic molecules by saying, well, that could happen on other planets. There is no reason why only Earth. And then there are the people who are philosophers who think, look, why would it only evolve here? It's everywhere. I remember I don't remember now his name. It's a priest which was in Rome in the 1600, who wrote articles about talking about life on other planets that could exist, and he was he was burned on the stake because it was heresy, and so people go back all the way to then, where they thought, well, maybe life exists somewhere else. There is no reason why it exists only here. And again, I mean, here we follow. Maybe I'm going a little bit off script here, where people say, well, but life exists only here because God created it here. And I say, yeah, it could be. I mean, independent of your religious belief, it's very possible that God created life here. But why wouldn't He create it everywhere? I mean, God is in charge of the whole universe. He could have created Adam and Eve on every planet in our galaxies and other galaxies. So there is no reason why He picked this galaxies and this little planet.
It's a lesson in humility. Maybe we're not that special.
Yeah, that is true. That is true.
When talking about technosignatures, and this goes back to your wife's very wise observation that we should expand our notion of what life looks like, in thinking about technosignatures, does that include thinking about life not in cellular form, but as electronic or computational beings?
Yeah, that could be. That could be. I mean, we, for people who have really broad imagination, I mean, it could be that it have evolved to that stage where it's technological. The more likely is that it evolved biologically, in the natural evolution, and could have evolved, like you were asking earlier, on the robots, which became so smart, that they kind of overtook the planet from the biological life, let's call it, and became a techno life. These are possible. I mean, you can make a good movie out of that.
That same year, of course, I'm curious, the Planck telescope, in what ways did JPL partner with the European Space Agency on this mission?
Yeah, we worked very closely with it, and particularly, I mean, clearly it's a European mission, the Planck telescope, and where JPL played a major role again is in the detectors. And that's an area when we collaborate with our particularly European partner as well as other partners on it, is the advances that we have in the US in detectors. And Europeans rely very heavily on us for many decades. Now they are developing their own capability. But they rely a lot on the US investment in detectors. So Planck were very closely involved in it because of the detectors. Matter of fact, one of the lead scientists on it is his name is Jason Rhodes. He's a scientist at JPL, and he's one of the lead scientists on the Planck mission. And there is agreement between NASA and the Europeans that the Planck data will be there is at the IPAC, or the infrared processing facility, would be an archive for that data for utilization by American scientists. So that's a perfect example of the close collaboration between Europe and the US in space exploration.
What was the value in collaborating with the Europeans on this, making it a worldwide or at least an international effort?
Yeah, well, I mean, the Europeans have their own program. They want to do research the way we do research here. And by doing the collaboration, which goes both ways, they participate on some of our mission, we participate on some of their mission. It enabled American astronomers to have access to that telescope, instead of only European astronomers. And that's common in the scientific world. There is a lot of very close collaboration. That there is not, you see very little national, hey, this is my telescope and we don't want to give it to our colleagues in Europe. There is a lot of that interplay. And I don't know how you track it back in history, but maybe part of it is on that we are a nation of immigrants. We have people who come from all over the world. As I mentioned to you, many of the scientists at JPL came from all around the world, particularly from Europe, but also from other locations around the world. So I think in the science community, there is that spirit of working together, with collaborator from all over the world.
Charles, tell me about the construction of the new visitor center and why that was so important to you.
Well, again, it was an issue, and unfortunately, we were not able to. We didn't get the funding, to actually do what we really wanted to do. It was really the outreach aspect, that and NASA was sympathetic, for these things. That it's important to have to reach to the public and get the public to really know about what we do. We do have a small museum, at JPL that people can visit. And it's a very exciting museum. I mean, during my tenure, we renovated it, we moved spacecraft in it, but it's not at the scale, of the museum like what you have down in LA. So we wanted to have a place where we can really highlight even more than what we have now. I think our museum now, I'm guessing it's probably about 2,000 square feet. And we jam it with a lot of things in it. And we get a lot of visitors who come to JPL. I mean, normally per year, as I mentioned earlier, we have like 20,000 students, and we get maybe 30, 40,000 people who come and visit JPL, and we take them around on tours. So that's why it was very important for the outreach. But I was able to achieve a lot of things, but every once in a while I was not able to get the funding, to develop the museum, the visitor center. But alternatively to it, what we ended doing is to have open house. So we started having at least once a year, sometimes twice a year, where we bring a lot of our spacecraft to the mall. We open a lot of our lab, and we open it to the public. And just in those, for a weekend, and just in those 2 days, we used to get 40, 50,000 people coming, to the point where the neighbors start complaining about the parking, where people were parking miles away coming in. And I remember one year, we really felt bad because it happened on that weekend. It hit like 100 degrees, temperature. And, it was really tough. I mean, we had people coming in wheelchair, people who were in there, elderly people, young people who came from other states, they took like from Arizona, to come to it. So then we established a process of having, people have to go online and get a ticket, not to limit the number, but to spread them, because we had no idea when people will show up. So sometimes we got huge number of people during one day and fewer in the second day. So I'm told now that before the pandemic, once we put them online, within 5 minutes, they are all taken. So JPL really has a very positive image in the public, and that's why we wanted to have a visitor center or a museum, if you want to do that. But we found alternative ways. And matter of fact, today with the internet, we do almost the equivalent, of a visitor center, because it's not only pictures, but we can get the public to see videos. We walk them around. They take a tour of JPL, on the videos. So we have, with a lot of the visualization technique, we can reach a much broader population, all around the world. Matter of fact, there is one program which we call Eyes on Earth, which was developed at JPL, where you can actually, on your iPhone, get all our data, images, of temperature across the globe, precipitation on your iPhone, almost in real time. Literally within hours of what we have that. And that's becoming international. Matter of fact, literally a couple of days ago, we were on a video conference working with colleagues in Saudi Arabia, where they took that program, translated into Arabic, and they were showing it at a museum in Saudi Arabia. So here you have kids in Riyadh, in Saudi Arabia, looking at the data that JPL is getting from our Earth orbiting satellite, literally that same day worldwide on doing that. So visualization is kind of taking a fair chunk of the outreach capabilities that the visitor center, would have done.
Charles, of course, outreach is good in and of itself, but it's also fuzzy in terms of measuring how do all of these outreach efforts come back and help JPL? So in all of your efforts to do outreach, to spark the curiosity of all of the people who are interested in JPL, what are some moments that stand out for you, either in an interaction with an individual or with talking to people, that you said to yourself, this is all worth it, it's so important?
Man, you hit on a very good and personal one. And let me tell you a story, considering that you want the history. I met my wife on a blind date. Her name is Valerie. And she was producing animation movies. And that was in the 70s. And at that time, they used to do them by hand. So on the first blind date, I took her out for dinner and then took her to Caltech, of course, to impress her. And on the second date, I took her to JPL. And I took her to a lab run by a guy called Jim Blinn. And he was doing the first work of using computer visualization, on animation and so on. And he was doing that to be able to visualize as our spacecraft are flying by. In that case, for Voyager, he was doing it specific. How do you see the planet? How do you visualize different angle? You rotate the spacecraft. It was very elementary. And she looked at it and said, Charles, this is going to put the animation industry out of business.
Oh, wow.
In a few decades, it's going to be done all by computer. Because at that time, they were still doing it all by hand on doing that. So that hit me at that time. And look what happened. Jim Blinn, after many years, got developed and he left. And I think he went and worked at Pixar and worked at Disney Imagineering. And now very few people do it by hand. Almost nobody does it by hand, anymore. So that was an event which really hit me about how visualization, computer visualization, is going to change completely our way of visualizing. And now you see movie, you think they are real, but in actuality, they are done by some of the technologies that Jim Blinn developed at JPL. So that's another example when people ask me about the benefit of space technology. I'm sure Jim Blinn was not thinking about doing animation, movies at that time. He was focusing on our spacecraft visualization. And JPL became a lead center about visualization. As a result of that, then more people were doing that. And that's what we did, this Eye on Earth, and we have a program called Eyes on the Planet, and so on. And now we don't think about it. It's a common industry. But I remember, and my wife regularly reminds me of what she told me, on that date 45 years ago.
That makes me think, of course, that if your wife had that amazing observation, she was able to extrapolate into the future. Just think what all of the people, the tens of thousands of visitors and the millions of visitors online, their exposure to what's happening at JPL, just think where their imagination is taking them.
No, absolutely. I mean, and I mean, the other example also that I give, which kind of relate to what you are saying, is on the camera, is, in your iPhone. The focal plane of that camera basically was developed, the technology was developed at JPL for our telescope, because we wanted to get very lightweight, very low power, focal planes. We never thought about them to be in iPhones. And some entrepreneur must have seen it or read about it, and they developed it. And fortunately, Caltech has a license for it. So now every time somebody buys an iPhone, Caltech maybe get half a cent from that. and it led to many tens of millions of dollars who came to Caltech, because of that development, and benefited all of us. I mean, now nobody thinks twice taking hundreds of pictures, with their iPhone. So that's another example where I don't know if it was somebody who visited JPL or read about it, which led to application that's not what we were thinking about ourselves. So, and I'm sure there are many examples, like that.
Charles, back to the missions. In thinking about the Large Binocular Telescope Interferometer, it's interesting, when does JPL decide to get involved in ground-based astronomy?
Well, our involvement in ground-based was mostly for testing our technology and working with the campus. So really the focus on the campus is for ground, telescope. And for us, the focus on participating in radio astronomy and the ground telescope is to go and test our technology and our instrument, before we develop them for space activity. So it's a great synergistic relationship between us and the campus. So every time we develop a new focal plane, we work with some faculty on the campus to put it in camera and go and test it at Mount Palomar so we understand its properties. Or, for instance, another example, kind of stretching it a little bit, is like for laser communication. We wanted to develop technology for using laser for communication to expand our capacity. And we started using Palomar as a receiving telescope because you need a big aperture. So it's basically demonstrating capability and technology before we deploy them in space, but also they benefit the ground astronomy community because they get those detectors and then it allows them to do better, capability on it, be it spectral capability or sensitivity or resolution. So we work very closely with the radio astronomy community, like at the Keck telescope, where we were demonstrating the interferometer, technology. We were thinking about space, but we wanted to demonstrate, can we do this? Can we really demonstrate, combining, optical signals? So we were very heavily involved. Some of our scientists were working very closely with the Keck telescope, project to do the interferometric, capability.
Charles, you mentioned the decadal survey, which now is coming out very soon. And with Keck, I'm curious, when the 30-meter telescope was being developed, did JPL play an advisory role? Were people talking with JPL at all in thinking about the TMT?
Yes. No, there was very close relationship. Matter of fact, at one time, one of the JPL project manager was was moved to the campus to work on that project. And the other capability is we were doing a lot of work at JPL on mirrors with adaptive optics, what we call adaptive optics. That means you have a flexible surface and then you have actuators behind the surface to control the accuracy of the surface. And the reason it's important for us, for space, is that when you launch a telescope, you live in a very different thermal environment in space. So it could distort the optics. And here we're talking a fraction of microns. So it benefits us to be able to have adaptive surfaces that after you launch, you can then adjust them so you can get a perfect surface. The story of the original case of the Hubble telescope where they had the wrong mirror. So if we had a flexible mirror with actuator behind it, we could have fixed it immediately on doing it. So we moved to an era where on future telescope, we wanted to have the mirrors, adaptable. And as we moved to bigger and bigger mirrors, we started talking about combination of elements. So you have smaller elements that you adjust. And that's a technology being used in the 30-meter telescope. So there was a lot of interplay. We learned from them and they learned from us, on how do you develop arrays of mirrors that you put together, and then you have actuators which adjust them to make it a perfect mirror. So yes, there was very close collaboration, and still there is close collaboration, with them.
While we're on the topic of TMT, of course, it's not your area, but with all of your perspective and connection to Caltech, the TMT is incredibly important to Caltech, and there's concern that the project might not go through depending on what the decadal says. How do you reflect on what this might mean for Caltech, and what does it mean more broadly for astronomy, given all of the political problems that we've seen in Hawaii?
Well, that is a challenge. Matter of fact, I from the beginning, I expressed, not concern, but to tell the people on the campus that this could become a problem because before we did, after the Keck telescope was developed, the Keck telescope was just 2 telescopes. We came up with the idea of maybe we can add 4 or 5 smaller telescopes, which will combine with the Keck telescope so we get even a larger area. And Ed Stone was the director still at that time. That was in the late 90s. And headquarters was convinced, so they funded us to build 4 smaller telescopes to be able to put them, in Hawaii. And we built the telescope. We were ready to deploy them. And then there was a big issue of the natives in Hawaii saying, oh, we are adding more telescopes and so on. And it went through a whole process of doing that. And we had to cancel those telescopes because we couldn't, get the approval and convincing that. So when the 30-meter was being, started, and there was a pushback from the local community, I kind of reminded Ed Stone, remember, what we tried to do and we were not able to do it, and he was aware of it. And I think Ed and Caltech and the UC have gone through a long effort to minimize the impact, including that the University of Hawaii was prepared to take off some of the telescopes which are already there, to make up back for it. They funded an education center. So I don't know how is that going to evolve. I mean, it would be a shame if it cannot be built, in there. I mean, for 2 reasons. One, it's scientifically very important in itself, but also in keeping the leadership of the United States, because the Europeans are building equally large telescope in Chile, and Chile welcomes them with open arms. So I do respect the Hawaiian, tradition. But I think in this case, there is room for some compromise, of working that, because I think it has huge benefit, not only for the U.S., but also for Hawaii, for educating, the native and the local Hawaiians, on educating them about science and enhancing their educational, capabilities.
In what ways is the decadal survey and its recommendations important for JPL and its missions that get funded or not?
Oh, no question about it. It's very critical because NASA follows literally religiously. They follow what the decadal recommend. And by the way, just for the benefit of people listening, there is a decadal for each discipline. So there is an astronomy decadal, which is going to come out shortly. There is a decadal for planetary, a decadal for earth science, and a decadal for heliophysics. And NASA follows very religiously, and Congress follows very religiously, what the decadal recommends. So yes, it is very important because the future missions that JPL will be doing or will be competing for will be based on what the decadal would say. And particularly in the case of astronomy, the decadal does not only address space, but it addresses ground telescope. Basically, NSF, the National Science Foundation, the astronomy division at the National Science Foundation, follows very closely what the decadal recommend. So the recommendation from the decadal will be very important, both for JPL and for the campus and for the broad science community, about what mission will be done in the future. And for the so the decadal does 3 things in a sense. One, it identifies the major missions that NASA will assign to a center. Also, they identify the scientific problems that could be addressed with smaller missions that the community can compete for, funded by NASA. And also, they address a ground telescope or ground experiment that then NSF, will fund for developing those, not only at Caltech, but at any institution in the U.S. So the decadal is lay out the groundwork for the whole field of what will be conducted in the following decade.
So what is JPL specifically looking for the decadal to say when it comes out in early November?
That's interesting. I know, again, I've been away from JPL for 5 years, but I know what there are. The one I'm aware of, there are 2 telescope missions, one which is called LUVOIR, which is advocated by Goddard, and it's a telescope even bigger than bigger than the Jim Webb telescope, which will be great. But I think the experience of the Jim Webb, the cost experience, that it ended costing $10 billion, started with $1 billion and ended being $10 billion. I don't know. If I was on that committee, I'll be a little bit worried about even a bigger telescope, despite what people would say, that could be. There is another one which is called HEBEX, which is advocated by JPL,